Today we're going to continue looking at molar conversions, much like we did on Worksheet 1, but we're going to add a little bit of twist to a couple of the problems here. All these questions in number 1 are done exactly the same as in Worksheet number 1, where we're converting moles or atoms to grams, and we're making sure we set up a conversion factor, taking the unit we're trying to get rid of and putting it on the bottom of the conversion factor and the unit we're trying to find on the top. Remember, whenever we're converting between moles and grams, we're using the molar mass off of the periodic table. And whenever we're converting between moles and atoms, we're using Avogadro's number, which is 6.02 times 10 to the 23rd. So what I would like to do is look specifically at questions 2, 3, and 4. Now these in question 2, you're asked to find the atomic weight of the following and in essence identify the unknown element. Now the atomic weight and the molar mass are the same thing. That's the number that we're given here on the periodic table, telling us how many grams there are in a mole of each substance. This is referred to as the atomic weight or the molar mass. The units for atomic weight are grams per mole. So we need grams and we need moles. And then we divide moles into grams to find the atomic weight. If we look at the example done here in 2b, you're given grams and you're given moles. So all we have to do is set up that fraction, divide, and find the number 50.9. And then we're going to look on the periodic table, and we're going to see that 50.94 is the molar mass of vanadium. So therefore, that is our unknown element in vanadium. Now what we need to look at here, if we look at 2c, 2c you're given atoms in grams. Well, we don't have moles, but we can convert atoms to moles and then divide that into 7.10 grams to get our molar mass. So that's what we're going to do. We're going to start out by converting the number of atoms that we're given into moles. So I'm just writing down 5.0049 times 10 to the 22nd atoms, and we're going to set up a conversion factor to convert that to moles. So remember, what we're doing here is we're taking the unit that we have here, atoms, and putting it on the bottom, and we're putting moles on the top. Now we know there are Avogadro's number of atoms in 1 mole of anything. So we're going to write in 6.02 times 10 to the 23rd. So we're going to take this, we're going to type in 5.0049. Remember to use that exponential button for the scientific notation. Then we're dividing that by Avogadro's number to get 0.0831378 moles. That's our number of moles of atoms that we have. Now we need to take this 7.10 grams and divide it by the number of moles that we found. So we have units of grams per mole. That'll get us our atomic weight, or molar mass. So we're going to take our 7.10 divided by 0.803138, and that gives us 85.4 grams per mole. So that's our atomic weight. And so in order to identify the atom, we're going to look on the periodic table, and we're going to see that the element that has an atomic weight of 85.5 is going to be rubidium. It may not be the exact same number, but it's going to be awfully darn close. So our unknown element here is rubidium, Rb. Okay? So it's about getting grams and moles and dividing the two. Let's look at question number 3. Question 3, we're asked to calculate the mass in grams of one atom. So we're going to look at 3C. And we're going to assume we have one atom of argon. So when it says you have one atom, that means exactly that. We're going to start with one atom of argon. And we're going to follow the steps to convert this through to grams. So my first step is to convert atoms of argon to moles of argon, the same way that we just did up here in this problem. We're going to divide it by Avogadro's number. Regardless of the element, whenever we're converting atoms to moles, we're going to use Avogadro's number. That cancels out our atoms. Then the next step, we can convert moles of argon to grams of argon. In order to find the number of grams of argon, we're going to look on the periodic table. And I see that the molar mass of argon is 39.95. So I'm going to put in 39.95. This step cancels out our moles. Now, we just simply need to do the math. So in order to do the math here, we're going to take the top, 1 times 1 times 35.95, which is 35.95, divided by Avogadro's number, which is equal to 5.97 times 10 to the minus 23rd. 5.97 times 10 to the minus 23rd grams. Now obviously that's going to be a really, really small number because we only have one atom of the substance. Make sure your numbers make sense when you're done. Now let's look at number 4. Number 4, we're going to look at 4A. In number 4, we want to know the atomic weight of the substance if one atom weighs 1.8 times 10 to the minus 22nd grams. So this is similar to number 2 and number 3. We want to find grams and moles. Well, we have grams right here, but we don't have moles. So just like we did in 2C, where we had to convert this number of atoms to moles, we're going to do that in 4A. The only difference is we're starting out with one atom. And so we're going to convert that to moles by dividing through by Avogadro's number, 6.02 times 10 to the 23rd. That number, if we clear out that from the last time, so we're going to take 1 divided by 6.02 times 10 to the 23rd, and that's going to be 1.6611 times 10 to the minus 24th moles. So now in order to find atomic weight, we're going to take this number of grams that we're given, and you're always going to be given the grams to the minus 22nd grams, and we're going to divide it by the number of moles. So we get units of grams per mole. That's how we find atomic weight. So we're going to put in 1.8673 times 10 to the negative 22nd divided by 1.6611 times 10 to the negative 24th. That's going to give us a value of 112.4 grams per mole. Okay, so which element has a molar mass of 112.4 grams per mole? I believe that's going to be cadmium right there. So the identity of our unknown element is indeed cadmium. So these are some examples of problems on worksheet number 2 where we're using the same unit conversion methods, the same conversion factors between grams and moles and atoms, but then maybe doing a little division at the end in order to find atomic weight or molar mass.